Hey guys, welcome to another Pytorch tutorial. So let's just start off very, very strong. So we are going to first import Torch. And after we import Torch, we're going to make a tensor. But this time we're going to use grad. Grad is the ability of Pytorch to basically find the gradient of a function. And I will demonstrate what it means. So for example, let's take a tensor called x. X is equal to torch.tensor of, let's say, 3.0. And does this require grad? You'll always have to set this as true. It is only then that you will be able to use it. Okay, so this is x. And now that x is grad, we can define maybe a function. So maybe I have a function like y is equal to 2x square plus 3x plus 2. Okay, so that 2x square is 2 star x double star 2. So this is 2x square plus 3x, that is 3 star x plus 2. So this, let us imagine that this is our uh, function for y. Okay, and x is equal to tensor dot is 3. It's a single value. So what do we expect y to be? We expect y to be 2 times 3 square. 3 square is 9. 9 twos are 18. 18 plus 3 plus 3, 9. Uh, that is 27. 27 plus 2, 31. So we expect a value of 31 from this function, right? And now we can do something very powerful. We can say y dot backward. This y dot backward basically initiates the backward pass to calculate the grad on this function. Okay, so this is what y dot backward does. So this, when we do print x dot grad, it is basically printing dy by dx. So in this case, all we are doing is we are printing the value of dy by dx, which is this, which is x dot grad. So let's have a look. So grad is the way by which you get the gradient. So let's actually run this. So tensor is 29. Dy by dx tensor is 15. Okay, wait, I think I might have, sorry, it's 27 plus 2. My bad. It's not 29 plus 2. It's 27 plus 2. Yeah, so it's 27 plus 2, which is equal to 29, right? It's basically 2 star 9 plus 3 star 3 plus 2, which is basically 18 plus 9 plus 2, which is 29. Yeah, so this is 29. So it's giving 29, which is correct. And the grad is 15. So what do we mean by grad? We can find this grad by differentiation. Which is x. If we were to differentiate this equation, that is 2x squared plus 3x plus 2, by using the rules, it would become 2 times 2x, so that is 4x plus 3. So if it's 4x plus 3, we expect the answer to be 4 times 3 plus 3, which is 4 3 is 12, 12 plus 3 is 15. So this is giving us the exact answer of what dy by dx is when we differentiate. So this is grad. Okay. Now going to part 2, we don't actually need to know the gradient of this. We need to know the gradient of the loss function. So usually this is a very simple forward pass that we did over here, right? Let's look at a way by which we are doing a backward pass. Okay, torch.tensor 3.0, we'll again keep the same thing. Okay, we'll put requires grad as 2 again. Okay, but this time we'll also put w. Okay, and we will sort of try to match the neural network uh, neural network simulation that we did before, because we've already made a neural network. So let's try to simulate that, right? So W, we can keep it as, let's take some random weight like 4.0. Okay. And does this require grad? Yes, this is also true. Okay. And then let's take a bias. So bias is again torch.tensor. Let's take this bias as 1.0 and requires grad. Okay. So now we have got xwb. So we can say y is equal to x star w. Oops. X star w plus b. Remember, it's actually supposed to be x at W. This is matrix multiplication, but because the singleton matrix is just one dimensional, we are just multiplying it. Matrix multiplication doesn't necessarily work. Right? It's supposed to be x at W plus B, but because it's a single dimension, it's not an array, I'm doing it like this. Okay. So now we have got y is equal to this, but now we usually have a target. So this y, the target should actually be 10. Let's take the target as 10. Then what is the actual value that what is the loss? So actually what we can do is basically literally what it says. So loss is equal to target minus y the whole square. This is because this is a loss function. If you measure the loss backward, right? Then let's actually just evaluate this, right? So y is equal to this before I even print all of this, right? What I will do is I will actually just print x w v. Okay. So here I can just say, whoops, I can say x is this, okay? And I can do w, and then I can do v, okay? So I can just do x, w, b. So I can say this, whoops, say this, and space over here, and sorry for the time. So there's x, w, b, and we'll print y also first, okay? So we print y is. So what do you expect y to be? In this case, x is 3, w is 4, b is 1. So 3 4s are 12, 12 plus 1, 12, 13. So we expect this to be 13. But ideally, our value should be 10. So for what value of w or x or b will it become 10 is what we are going to try to find out using grad. Yeah, so right now we have got 3, 4, and 1, x, w, b. Now y, the tensor is showing 13 exactly as we predicted. So this is the value of y. But now the target is 10. So what is the loss? So the loss is actually what's the error? So actually, I will go by this. So the error is equal to, okay, the value of y minus target, okay, or target minus y, whatever you want it, right? So you can say target is y. And the loss function can also be written as loss is equal to error whole square. Why is it error whole square? Because let's say this value was lesser. Let's say it was 7, right? So 10 minus 7 will give a positive value, so error is 3. That's fine. But if it is a bigger number, it is 13. So 10 minus 13 is negative 3. So the error is negative. But we always want to measure the error as a positive number. So we square it, right? So this is what we have done. Loss is equal to error square. That's basically what we're doing. Now that we know that loss is equal to error square, we can actually go backward because we have put requires gradient true. We can go backward on the loss. So then when we print x grad, what exactly are we computing? We are computing a very simple thing. We are computing, let me show you, dl by dx, where L is the loss. That's what we're trying to compute. Okay. So we are computing dl by dx in x grad. And now the same thing, if I were to do for W, it is dl by dw. And the same thing for this will be dl by dp. So this direction of grad will indicate how much, in which direction the slope must go. So let's actually compute it. So we can clearly see that it is 24, 18, and 6, right? What do these numbers even mean? It just means that the gradient of x is positive 24, right? The gradient of x is positive 24. That means it must become a more negative value, okay? It must become a more negative value such that it can accommodate or it can get closer to the target value of 10. That's all it means. For example, now you can see it's 24, right? And now we clearly saw x is 3. So if we make it slightly smaller, let's make it 2.5, right? So let's make it 2.8. Okay. Observe how the gradients move. 24, 18, 6. Do you see it? It's 17, 12, 4. Now it's become smaller, right? Now let me continue to make it smaller. Let's keep making it till it sort of matches the value of 10, right? So 2.5 star 4 is 10, 10 plus 1, so it'll be 11. So now the value will be 11. So if you see this, look at that. They have further reduced. And now if I were to go, let's say a smidge lesser, that is 2.25. Okay. So if I were to do 2.25, what would I get? I would get 9. 9 plus 1 is 10. So this is 0. So now the gradient I expect to be 0, because when it's 2.25, the value of y will be 0. So the error will be 0. So the gradient should be 0. Let's see. It is 0, negative 0. There you go. This means that it's achieved it. So the farther I am from the target, the more it does, right? So for example, even if I were to take this, right, 24, 18, 6, you can clearly see that this one is there. 3 times 4 is 12. But what if this was negative 2, right? Now look, it's again 0, right? Are you getting an intuitive understanding of what gradient indicates? Gradient basically indicates a slope. Y is equal to mx plus c. So when the slope is positive, that means you have to remove this value, remove a larger value from that term to get closer to the final answer. We will be using this later on to try and basically uh, build a small feed forward, a simple neural network, right? So just to summarize, the positive gradient indicates an increasing parameter, negative gradient increasing parameter decreases loss, and magnitude is how sensitive the loss is to that parameter. So the magnitude is the amount by which it is sensitive. Uh, does that make sense? And we are going to do this multiple forward pass and backward pass, and we look at gradient accumulation as well after this. So I hope you liked this small part, this small tutorial. If you have any doubts, you can sort of reach out or comment or something, or you could even consult other YouTube videos. This is a very simple thing. So all we're doing is we're just finding dl by dt. Let me wait, and one last time, let me just give you a counter example. So all of these times the value has been like larger. So let's say we want to make this value much smaller. So let me make it 1. Let me make it 1, and let me make it 1. So now I expect the answer to be 3, right? So now you will see a negative gradient. Keep seeing. You see, there is a negative gradient of 16, right? And now intuitively, it's a bit difficult for you all to understand. I can actually show you how the gradient accumulates, but we'll do that in the next video. Okay. Thank you.